I'm glad to be here with you today. My name is Daniel Bowers and I'll be your instructor. Today we're going to talk about how to solve problems with variables in the SAT. And a lot of times you don't even really need to know the math here. You don't need to know how to set up things algebraically. You can there's some tricks you can use even when you don't 100% remember the math or it just looks confusing. Alright, the first problem, it's asking how many seconds are there in m minutes and s seconds. And so we can just set this up by making very simple variables, and we can plug this back in and find out which one of these equations works. Alright, so what we're going to do here is we're just going to have the m be 1 and the s be 10. So therefore the number of seconds we're looking for is 70, with 60 seconds being in a minute, and then we add that with the then we add 10 extra seconds on there. So alright, what we're going to do is we're just going to plug these variables in and try out each one of these equations until we find the right one. Alright, first one gets us a result of 660. That's not right. Second one gets us a result of 601. And then finally we get the correct result of 70. So we know we found the right answer. Alright. Then the next one is, this is talking about fractions. And it says the numerator of a certain fraction is 5 less than the denominator. If the fraction is equal to 3/4, what is the denominator of this fraction? The key word here is denominator. Okay, and what we're going to do is we're going to work backwards. We're going to plug in denominators, and I've found that it's most effective if you start with something in the middle of the range of answers, so then you can decide if you're going to go above or below. So here you plug in the 16 as the denominator. That's the middle of the range, and that would make the numerator have to be 11, because 5 less than 16 is 11. That will not convert to 3/4. So what I'm going to do next is I'm going to decide to go on to higher values. Alright, so when we go on to 20, this would be 20 minus 5 would be 15, so the numerator would be 15 and the denominator would be 20. This nicely converts to 3/4, so we have solved this problem. Okay, and then we have, this is a word problem that we need to convert into math. It says here, if 30% of m is 40, what is 15% of m? Okay, and really we need to do some translations here. Okay, so when you see is, you should translate it into equals, and of should mean multiplication. So you know, I put the x, you know, that's the multiplication sign, and percent should be converted into fractions. So and that would always be with 100 as the denominator. Okay, and so when we translate this, the percent goes to 30 over 100, which would also be 0.3. So it'd be 0.3 times m would equal 40. So dividing both sides of the equation by 0.3 using your calculator, and you're permitted to use calculators, so this would be a good time to use it, you'd have m equals 1.3 repeating. Okay. And then, so the word what, that's introducing a new variable. We're going to call this n. And 15 over 100 will be the conversion of 15%. And also that translates into 0.15. So what we're going to do is multiply 1.3 repeating times 0.15. And when we use a calculator here, we get 20, which is the answer. Alright, a lot of people see inversely proportional, they're like, what does this mean? They're freaking out. But really, inversely proportional, it's a fairly simple concept. What this means is that one of the values goes up.